Can you guys hear me right now?
Yes, sir.
Yeah, okay, cool. Yeah, thank you. Okay, so this is the post-contest discussion session for the Codeforces Dev 3 contest conducted by TLE Eliminators. I'll start with the start with the post-contest discussion now. Okay, so yeah. Okay, this was the first problem of the contest. The problem was called only pluses, and uh, in this problem, there were three integers that were given to us in each test case. Okay, there were three integers, and uh, what we can do is we can increment each of the integers, any one of the three integers. We can increment any of the one of the three integers by one in one operation, and we can do this increment at most 5 times. So say we pick integer a and increment it by 1 once. Then we can pick b in the next operation and increment it by 1 again. So this is basically what the problem statement states. And what? So yeah, say we have 5, 2, and 3 as our three integers. What we can possibly do, what we need to do is we could increment any of these integers by 1 such that the product with which we get is maximum, and we can perform this operation 5 times. So in this case, what you do is you'll first increment 2 to 3, then this 3 to 4, 3 to 4, I mean, and yeah, this 3 to 4 again. So we have performed how many? 4 operations so far, I suppose. Yeah, 4 operations so far. Then we could again increment this 4 to 5. Okay, so we are performing 5 operations over here, and the three numbers we'd have after this is 5, 5, and 4. Uh, and multiplying all of these three, we would get 5 into 5 into 4 is equal to 100, which would be the maximum that we get. It can be seen that now nothing higher can be obtained. So how do we algorithmically solve this? Something that you'd have to notice is when there are two numbers, let's say there are two numbers a and b, and you want to and you could increase one of these numbers by 1. Okay, you could increase one of these numbers by 1 such that a into b after the increment is maximum. Okay, after the increment is maximum. In this case, what you would try to do is find whichever is the smaller number in these two. Okay, so suppose you have 5 and 2 as a and b, 5 comma 2 as a and b. In this case, what you would try to do is you try to pick the smaller number, which is in this case 2, and increment it by 1. So you'd have 5 comma 3 after that. And in this case, a into b would be 5 into 3 equal to 15. Say on the other hand, you increment 5 to 6. Then you'd have 6 into 2, which is 12, which is obviously smaller than 15. So yeah, that is something that's provable. That's something that's provable using some algebra. But yeah, that's the way you would have to see. To see why that's true, say you have a and b such that a is greater than b. It's optimal to increment b by 1 to get a bigger number, because if you increment b by 1, the product is going to be a into b plus 1, which is ab plus a. So since a is greater than b, it's optimal to increment b over here. Okay. On the other hand, you'll have a plus 1 into b would give you ab plus b, which is smaller than ab plus a because a is greater than b. So it's optimal to increment b. So that's the fact that you'd need. So after that, since you do this operation 5 times, what you do is repeatedly, you pick the minimum of the three numbers. You have a, b, and c. So you pick the minimum of these three and increment them by 1 in one iteration. In the next iteration, you do the same thing. So say you increment b by 1 in the first iteration and c becomes the smallest one in the next iteration, you increment c by 1 and repeat this 5 times. And finally, whatever three numbers you get, you multiply them and output them. That's the way you solve this problem. Okay. So I'll just show my code now for this problem. So yeah, the templates that I've used over here is SCD is basically just inputting T. Okay, that's similar to C and T, and F range. F range is basically a for loop from 0 till T minus 1. That's what the for loop is. Okay, 0 to T minus 1 is what F range stands for. And yeah, VI is a vector integer, and F range is the same thing as I explained. Yeah. And all is vec dot begin comma vec dot end. That's what all is. Okay. So what I'm doing is I'm inputting the three integers into vec I, and I'm sorting the vector, sorting the three integers to, and the first integer would be the minimum value, and I am incrementing the minimum value by 1, and I'm repeating this 5 times. And finally, I'm multiplying all the three numbers and outputting it. That's basically the solution for this problem. Okay. We'll move on to the second one. The second problem was called Angry Monk. And what is the problem statement? Okay. In this problem, there is like an n meter long wire. Say you have an wire which is n meters long, and this wire has been cut into k pieces. Okay, this wire has been cut into k pieces, and each of these pieces are a1 to ak in length. Okay. What you could yeah, your aim is to combine this all these pieces into a single one at the end. So there are two types of operations that you can perform. You can pick a wire with length ai with such that the length is greater than or equal to 2. So the length should be greater than or equal to 2, and you can divide that wire into two pieces such that one piece is of length 1 and the other piece is of length ai minus 1. Okay, so you divide them into two pieces, and you another operations that you can perform is you pick a slice of size ai and another slice of length 1, and you combine them. Okay, so after that combination, you get a single piece of length ai plus 1. Okay, so these are the two types of operations that you can perform, and you need to find a way to combine all the wires into a single one. That's basically what the problem statement says. So something to notice from the problem statement is when you have a wire of size length 1, you can combine it with a larger one to get a different wire. But if you have a longer wire, you would need to split it up into pieces of 1 before starting the combination. So there are two steps for each separate wire. Okay, you need to have a final final wire of length n. Okay, so you need to split all the wires into lengths of wires of length 1 and start combining them together. So the first step would be making all the wires equal to length 1. That should be the first step. The second step would be combining all the pieces of length 1 into a single stretch. Okay, these are going to be the two steps. So but you don't actually need to split every piece into pieces of length 1. Why is this so? If you split every piece, there will be at least one piece such that if you which could be the base piece. Say a piece has length 100. You could whenever you get other pieces of length 1, you could just add that to this single piece of length 100 and get this would be the base piece. Okay, so you don't need to split that into wires of length 1. You can just add all these smaller wires to this directly. Okay, so yeah, I'll just start explaining what I mean with an example. Let's take example number, say 2. That we have two pieces which are length 3 and 2. We have two pieces which are of length 3 and 2. The first step, what we try to do is we just leave this wire of length 3 as it is for now. And the wire of length 2, in one operation, we will split it into a wire of length 1, two wires of length 1. This would be our operation, first operation. The next operation would be combine this wire of length 1 with this wire of length 3 to get a wire of length 4. Then you combine these two to get a single wire of length 5. So yeah, these are the two operations that you would perform and finally get a single wire. So what you'd notice over here is the longest wire could just be left alone. So the longest wire would act as the base wire, and all the other wires will be chopped up into smaller wires of length 1, and those would be combined to this larger wire. So those would be pushed into the larger wire. So that could be the algorithm to solve this. So yeah, the larger wire would not be contributing anything to the operation. So we'll just let it be alone. Okay. For each of the smaller wires, how many operations would we need? So to look into that, the number of operations required for each smaller wire, say the length of the smaller wire is some length, let's say we have, let's say this is a test case 5, 3, 1. This is a test case. And the wire of length 5 would just be left alone because that's the longest wire and we don't need to split it up and waste operations. Okay, so we'll just let it go. And this is the second largest wire. So how many operations would be needed to add this to this wire? One operation would be to split it into 2, 1. This would be one operation. The second operation would be to split this into, this 2 would need to be split into 1, 1. That would be the second operation. So you have 3 wires of length 1, 1, 1 arising from this single wire. Okay. So what you do is you'd add all of these into this base wire. So one operation to add this one operation to add this wire, and one operation to add this wire. Okay. So in total, you'd require 3 operations to perform this. To perform this addition, and 2 operations for the splitting. In general, given a wire of length x, okay, to split it into pieces of length 1 each, many pieces of length 1 each, that is, you'll split it into x pieces of length 1 each, you'd require x minus 1 operations. And secondly, to split, to combine all these x wires of length 1 into the base wire, you'd require an additional x operations. So in total, you'd require 2x minus 1 operations. So for each, the contribution of each small wire to the total number of operations required would be 2x minus 1. So how will, what would be the algorithm to solve this problem? Once you input a vector containing all the wire lengths, you sort it. Okay, you sort it by in ascending order, and except the last element of the vector. Okay, except the last element of the vector, you sort the vector, and for all elements except the last element of the vector, you add total into total. You add total plus equals to whatever the size of that element is. So let's say the size of the element is x. So total plus equal to 2x minus 1. The contribution 2x minus 1 is shown over here. Okay, the how I cannot drive that is shown over here. So you add that to the total, and yeah, finally you output this total. That's what you'd be doing to solve this problem. Are there any doubts so far? If there were any doubts so far, feel free to ask in the chat. Otherwise, I'll just move on to the code. Feel free to ask it. Or feel free to unmute too. Okay, I hope there were no doubts. So I'll move on to the code of this problem. So yeah, here is the code. Yeah, the templates are basically the same thing that I told in the while explaining the previous problem. And yeah, I'm inputting all the elements into the vector, and I'm sorting the vector. And for all the elements except the last element, so up till k, so that's why it's k minus 1. I'm adding 2 into vec I minus 1 to the total. So, okay, so then I'm outputting the total. That's basically it for this problem. Okay. Okay, we can move on to the third problem then. Okay. For the third problem, you're required to construct a permutation such that permutation. Okay. In this permutation, there are two functions that are performed on this permutation. That is g of I. In g of I, up to the the elements up to the ith element of this permutation are considered, and the sum of all the elements which are lesser than or equal to m up to that element is added to the total. Okay, and that's what g of I is. And the other function is f of I. And f of I, similarly, the elements up to I are considered, and all the elements which are greater than or equal to k is added to a total. Okay, the is added to the total and outputted. That's what f of I is, and that's what g of I is. Okay, so yeah, I hope the definition of f of I and g of I made sense. So after that, you're calculating the summation of f of I from for I equal to 1 till I equals n. Similarly, you're calculating the summation of g of I from I is equal to 1 till I is equal to n, and the difference of the summation of f of I and the difference of summation of g of I is calculated, and this value needs to be maximized. That's basically what the problem statement says. So you need to construct a permutation such that this value is maximized. So how do you do this? So for this, you need to find a way to such that the summation of f of I is maximized and the summation of g of I is minimized. These are the two conditions that you need to make sure while you're constructing the permutation. To ensure that the summation of some f of I is maximized, one thing that you try to ensure is that all the elements that are greater than or equal to k and are placed at the first beginning of the permutation. Okay, so any element which is greater than or equal to k contributes to f of I. So you need to ensure that all the elements which are greater than or equal to k are placed at the beginning. And you'd also try to make sure that the elements which are less than or equal to m are pushed to the end. Because if they are at the beginning, they would contribute to g of I, and that's not ideal. We want g of I to be minimized. So you try to push them to the end. These are the two things that you need to make sure. Okay. And when you're pushing all the elements which are greater than or equal to k, it's obviously ideal to place the bigger elements at the beginning. Okay, so say let's just take one of the sample test cases. Uh, okay, we'll just create our own test case. The sample test case will not be a great way to showcase this. So let's say the input is n is equal to 5, m is equal to 2, and k is equal to 4. So let's say this is the input. What are all the elements? So all the elements which are greater than or equal to k need to be pushed to the beginning. And while ensuring this, it's also ideal to make sure that the larger elements among those are pushed at the beginning. Now, what I mean by this is when you just ensure this condition greater than or equal to k is pushed at the beginning, this is valid. 4 as the first element and 5 as the second element is valid. But it is going to be more ideal to make it 5 as the first element and 4 as the second element, because then 5 is going to be placed in two prefixes. It's going to be placed in I is equal to 1 and also I is equal to 2 prefix. But on the other hand, placing 4 as the first element and 5 as the second element will make it so that 4 is in two prefixes and 5 is only in one prefix. So it's ideal to choose this. So that's the first condition that you try to ensure. Then what is the second condition? The second condition is that place all the elements which are less than or equal to m at the end. So elements less than or equal to m are 2 and 1. Okay. You'd want to place them at the end. Again, by the similar logic, just the inverse of that, since we need to minimize g of I, it's going to be ideal to place the smaller elements at the beginning. Instead of 2, 1, it's going to be ideal to place them as 1, 2. Okay, so 1, 2 is going to be ideal. So yeah, we have placed the important elements in the required positions now. The other elements, like in this situation, only 3 is not in any of the ranges. It's not greater than or equal to k or less than or equal to n. In other cases, there might be multiple numbers which are not in any of the ranges. Those numbers can be ignored. We don't need to care about them. Okay, so 3 can just be placed in the middle. Okay, so the two conditions, the required conditions are place all the elements greater than or equal to k at the beginning and sort them in descending order. Okay, sort those elements in descending order. Then place all the elements which are less than or equal to m at the end and sort them in ascending order. Okay. Then whatever elements are left, any arbitrary element that is left, just place it in the middle, place it anywhere you want. You don't need to worry about their positioning. Okay, so yeah, that's the way you'd solve this. I hope the solution made sense. If there are any doubts, feel free to ask in the chat. Other than this, we'll move on to the solution. What is the solution? Okay, so yeah, this is the code. In this, I'm inputting an n, m, and k. And as I told before, like what I'm doing is all the elements which are greater than or equal to k, I'm printing them. And to print them in descending order, I'm starting at n and moving towards k. Okay, so all the elements greater than or equal to k are printed over here. Okay, Zunzar, which part did you understand, by the way? Like, I can't explain.
Sir, the solution ones, this 4 and 5 means F1, how F1 and G of I is determined.
Did you understand how f of I and g of I work? What are they? Like, did you understand the definition? Like,
No, sir, not exactly, but some of the part I understood it.
okay, you didn't understand the problem entirely, the problem statement. That
Yes, sir.
okay, cool. Yeah. Okay, I'll try to explain that quickly. So basically, what f of I is, say m is equal to 2, and the permutation we have is let's say 5, 2, 1, 3, and 4. Okay, what f of I is, let's just try to calculate f of 2. Okay, let's try to calculate f of 2. uh for f of 2, we'd only consider the elements up to the second index. Okay, so 5 and 2 are the elements that we need to consider. That is the prefix up to index 2. Those are the things that we need to consider. And we would sum all the elements up to this point. Okay, so the elements up to this point are 5 and 2, and if we just naively sum them, we'll get 7. But the condition for f of I is we would only have to include the numbers which are less than or equal to m in our total. Okay, so m is 2 in this case, so the numbers which are less than or equal to m is only 2, so the f of 2 would be equal to 2. Did you understand what f of 2 is?
Yes, sir, means the element less than or equal to 2 will be considered.
So similarly, if for f of 3, do you get what f of 3 is? Can you just tell me what would
F
f?
of 3 would be 3 and 2.
No, f of 3 would be f of 3 will only be 3, right? Because you would add 2 and 1. Up to this element you'd be considering, and 2 and 1 are the elements which are less than or equal to 2, and f of 3 would be 3.
Oh, yes, sir, yes, sir.
So the sum of this, and yeah, just what would f of 4 be? Then f of 4.
F of 4 would be 5, 6.
No. since m is equal
3
to
and
since m is equal to 2, you wouldn't be adding 3, right? M
yes, yes, yes.
so so what would be the answers for that? What would f of 4 be?
F of 4 would be 2 to itself, because we are not adding 3 to it, because m is equal to 2.
Yeah,
So we can,
we would be
yes,
adding 2 and 1. So the answer would be 3 in that case. 2 plus 1 equals 3. Like you'd be
okay,
adding these two, right? Okay.
yes,
So you understood the definition of f, right? The function f. Did you understand the
yes,
definition?
sir.
Okay, cool.
Yes, sir, yes, sir.
So I'll just explain G too quickly. So what G of I is, so like the prefix thing is similar. You'd consider up to some index I. Okay, so that's what you would be considering with G. So then there would be some value K. Okay, so let's say K is equal to 4. If K is equal to 4, what you'd be doing is only the elements that are greater than or equal to 4 would be added to the sum. So let's say you have here you have 5, 2, 1, 3, 4, right? In this, say you consider G of 3. You'd only be adding elements which are greater than or equal to K to the sum. So G of 3 would be 5.
5 itself.
Yeah. What would G of 5 be? Can you just try to answer that quickly?
G of 5 would be 5 plus 4, 9.
Yes, yeah.
Because,
Yeah. So yeah, I hope you understood the definition of G of I too. Okay.
yes, sir, yes.
Yeah. So basically what according to the problem statement, what you'd be doing is you'd be summing up f of I from I is equal to 1 till I is equal to n. That would be one value. And you'd be summing up G of I from I is equal to 1 till I is equal to n. That is going to be the other value. Okay. So, and you'd be finding their difference. This difference needs to be maximized. So you understood this part, right?
Yes, sir.
Okay. So, since you'd be trying to maximize, 1 second. Okay, I think while explaining, I just swapped the definition of G of I and F of I. Okay, just swap it. I just swapped it. Okay, but like the explanations are correct, but the terming were wrong. Okay, just swap that. And yeah, so you need to maximize F of I. In f of I, all the elements which are greater than or equal to k will contribute to f of I. So by maximizing f of I, it's ideal to place these elements which are greater than or equal to k at the beginning. Do you understand why? Like if they are placed at the beginning, then those will contribute in many prefixes. So it will contribute in f of 1, it will contribute in f of 2, it will contribute in f of 3, and so on. So if the elements which are greater than or equal to k is placed in the beginning, the contribution of such elements would be graded to the sum. Do you understand this point?
Yes, sir.
Okay. So yeah, that's why you'd be placing elements which are greater than or equal to k at the beginning. And you'd also not want, you'd want to minimize G of I. So to minimize G of I, you'd ideally want to place the elements which contribute to G of I towards the end. So they are such that the number of times they contribute in each prefix will be less. So all the elements which are less than or equal to m would be pushed to the end. That's what you try to do. So in this case, m was 2 and k was 4. So you place 5 and 4 at the beginning. They are greater than or equal to k. So since you want them to contribute more, you place them at the beginning. And you place all the elements which are less than or equal to m, which are 1 and 2 at the end, because you want them to contribute less. Okay. So those are two important conditions that you need to make sure happen. Another two smaller conditions. Okay. These are like sub conditions. The two sub conditions are among the elements which are greater than or equal to k, It's ideal to place the bigger element at the first position, the second bigger element at the next position, and so on. Okay, that's what we'll be doing. Okay, do you understand why we are doing this? Because if you have the biggest element 5 over here, it will contribute to f of 1 and to f of 2 also. Okay, and the second smaller element 4 would only be contributing to f of 2. The second element will only contribute to f of 2. So it's better to place the bigger element at the beginning such that it contributes to more prefixes. Did you understand that point?
Means we are just calculating the prefixes and then subtracting it from the other one.
Like we'll be like some calculating f of I and summing it up, right? So 5 would contribute to if 5 is at the first position, it will contribute to f of 1, f of 2, and so on. It will contribute to all of them. It will contribute to all f of 1, f of 2, and so on. On the other hand, if 5 is at like in if 4 is at the then 4 will only contribute to f of 2, f of 3, and so on. Okay, we want the bigger number to contribute more. That's why you're placing 5 at the beginning. Okay, did you understand that?
Yes, sir.
Yeah. And similarly, since we want to minimize G, we would place a smaller element of which contributes to G of I at the beginning. Like you, instead of 2, 1, you'll place it as 1, 2. Like that's the same logic, but just the reverse of it. Here you place the bigger element at the beginning since you want to maximize it. For G, you want to minimize it, so you place the smaller element at the beginning. That's so yeah. Did you get the logic behind that? Huh? Are there any other questions? Feel free to ask if you didn't get the last point. Okay, I suppose I can continue then. Did not. That made sense, right? If you didn't get it, like, feel free to let me know, or else I'll move on to the next problem. The code basically does the same thing. So all the elements which are greater than or equal to k that is contributing to f of I are printed at the beginning of the permutation. Those are outputted for the first part of the permutation, and they are in descending order. So I start from n and move up till k. And these are all the elements that don't matter. So you can just place them arbitrarily in the middle. So m plus elements from m plus 1 till k minus 1 don't matter. They don't contribute to g of I or f of I. So you'll be placing them in the middle. The elements which contribute to g of I are 1 to m, or 1 to m are the elements contributing to g of I. So those would be placed in the end, and the smaller element will be placed in the beginning. So I'm looping from 1 till m and I'm outputting them. That's basically what I'm doing. So I suppose we can move to the next problem if there were no doubts. So Zunzar, was the third problem clear now? Like, do you have any other question?
Yes, sir. Yes, sir.
Okay, cool.
Yes, it's clear.
Yeah. Okay. Once. Okay. In this problem, you have a river which is of length n. Okay. So we want to swim across this river. That's basically what we need to do. But the river is very cold. So in total, the distance we'd have to swim cannot be more than k meters. K is the maximum distance we can swim in the river. Additionally, there are crocodiles in the river. If we ever meet a crocodile, we can't cross the crocodile. If you meet a crocodile, we can't cross that point. We'd be killed. Okay, so yeah, we cannot land on a segment which contains a crocodile. Additionally, there are logs on the river. We can get on top of a log. We can get on top of a log. So we can get on a log and jump to another position from that log. From a position, we can do multiple things. If we are on a log or like a river bank, we can jump forward. We can jump forward more than not more than m meters. Okay, so we can jump at most m meters to some other position. That's one operation that we could do if we are on a surface. If we are on water, we can swim to the next segment. If we can swim to the next position if that is another water or a log or the river bank. We can do that if we are on a water. If we are on a segment with a crocodile, we cannot move forward. That's it. Okay, so if we land on a segment with a crocodile, like that's the end. So we just can't do that. So yeah, through this, like these are the three possible operations. With these three operations, we want to see if it is possible to reach the end of the riverbank, like if it's possible to reach the end. There are like multiple ways to solve this. This is probably solvable using like disjoint sets, or you can just solve it like okay, disjoint sets might be like too complicated to solve using, but what I solved was I just started. Okay, I'll try to explain what I did. Okay, there are probably like many ways to solve it, but this was my solution. So I hope the problem statement made sense. If there are any doubts in the problem statement, like ask now. Otherwise, I'll move on to explaining the solution. You're starting at position 0. Okay, you can move m steps. Let's say m is equal to 3. And we'll just take one of the test cases. Okay, let's just take the first test case for now. In the first test case, we have in the first test case, once again. For problem D, can you explain this test case? Okay. So the test case you want me to explain is CL is the string given and M is equal to 1 and K is equal to 2. Okay. No, the reason why the answer is no is you start at position 0. You start over here. You cannot directly jump to this position. Okay. You can only jump at most one step because M is equal to 1. So you would only jump to C. But C is a crocodile. So you cannot move to that position. Therefore, you cannot cross the river. Okay. Yeah, Swar Bhatia, that's like the correct explanation for that. Thank you. So yeah, we'll just take the first sample to showcase how I solve the problem. So in the first sample, this was the string given L, W, L, 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 and a W. And you have M is equal to 2. And K is equal to 0. So basically in this test case, you just can't swim. You can only jump and cross the river. So you start at position 0. What I did was, we always start at a land. Okay, we always start at a land. So I tried to jump to the closest land from here. Okay. Whenever we started to land, I tried to jump to the next closest land. In this case, from position 0, the closest land would be L. I jump there and stop there. From this position, in the next step, I just try to jump to the next closest land. This point is not a land. I try to jump to the next closest land, which is L. Since m is equal to 2, we can jump directly here. We can jump 2 steps, so we can jump directly here. And in the next step, I jump to the next closest land, which is this L. We just jump 1 step forward over here. Again, I repeat the same thing and come to this point. And finally, I move to the end. So if for this test case, you can just jump around and move to the bank. Okay. Okay, so there are two questions in the chat. Vineet Kumar, so it is not like the thing is it's not written the last segment is given to be the segment n+1. Okay, n+1 is a bank. N+1 is not a part of the river. So you start at the left bank and you reach the right bank. The bank is not going to contain water or log or a crocodile. So it's just going to assume it's safe over there. And okay, yeah. Swarbat, yeah, that's fair. You can, in fact, directly jump to the last log within your jumping range. That is going to again work out. So this is basically what I did, but what you have mentioned in the chat is also correct. Either of these ways would be working. Okay. So yeah, for this particular test case, it worked well and good that you could always reach a log. Okay, there is always a log within our jumping range. Okay, but this might not always be the case, and we might need to swim at times. So we'll just take up some other test case to look at that. Is there some test case which? Okay, there is not a great example to showcase that. Let's just create our own test case then. Let's say LWWW LL and K is equal to 3 and M is equal to 2. We start over here. We start at position 0. And Vineet Kumar and Swer Bhatia, I hope you understood what I told for this. Are your doubts cleared? Just mention in the chat. Okay, cool. So from position 0, you can move 1 step forward for the first position. So you jump 1 step forward to the first log. And then since m is equal to 2, you can't just directly jump to the next available log. It's because the next jump is going to be 4 steps long to reach the log. So in that case, what you try to do is you just try to jump as long as possible. Okay. If you jump as long as possible, you reach this water. And after that, you try to swim as much as till you reach some log. So you need to try swim 2 steps and reach this log. And after that, you update K. Since you have swam 2 steps, K would be updated, decremented by 2. K minus equals 2. So K becomes 1 after that. Since you have already swam 2 steps. Then after reaching this L by swimming from here, you can just jump twice and reach the final bank. This is basically what I did. Yeah, Naveen, what you're told is like a fair way to look at it. It is, yeah, if there is water before crocodile, it's never going to be safe to reach that water. So yeah, but I didn't need to do that. So like, as I told before, this is basically just a simulation problem. So you just try to implement what is there given in the problem statement and get the output. And there are going to be many ways to solve this. So any way that many ways that you are going to be valid to solve this. And yeah, that's like a good observation. I mean, like, yeah, if you find like water before a crocodile, you can convert it into a crocodile. Rating predictions for this question, like I'd probably give it like 1,300 or 1,400 max. Like 1,200 to 1,400 would be the range. I guess 1,300. 1,300, yeah, that would be a fair prediction. DIP gave MLE. What were your DP states? Garv Aurora. I suppose Garvara's type in this DB state. I saw like that was basically the way to solve the problem, but this is basically an implementation problem. So there isn't too much to explain, but rather just how a way to implement this. So I'll just showcase my implementation and say how I implement it. But obviously there are going to be my other ways or even say easier ways to implement this solution. So what I did was current is the position that you're at right now. And you can jump at most M steps. So I'm trying to jump M steps and seeing if that position is a land. If that is a land, I'm going to that position and stopping over there. If current is greater than or equal to N plus 1, I'm breaking because you have reached that final position and yeah, you can just stop over there. Otherwise, I'm continuing to the next spot. And yeah, if the last position is equal to L, then I'm continuing. Yeah. If string L minus current minus 1, okay, Garvarora, but wouldn't that become like N into K complexity? Like, so yeah, so that would be MLing because N is up to 10 to the power 5, I think, and yeah, N and K are up to 2 into 10 to the power 5, and the memory complexity would be O of NK, and that's going to be a very large number. That's going to be 4 into 10 power 10. So for memory, it's going to be like up to 10 to the power 8 or 5 into 10 power 7 is going to be like the limits depending on the memory limit given for the problem statement. And that's obviously going to ML. So yeah, in this thing, what I'm doing is I'm moving to the next closest land. Okay. I'm assuming that whenever we enter this while loop block, current position is always a land. That's something that I'm assuming at the starting. It's obviously true because 0 is the bank and that is going to be a land. And for the further forward iterations, I'm assuming in the steps over here that we always end up in a land when we end one block of iteration. Okay. So for that, if I'm trying to jump at most M times and seeing if I reach a land block. If I really reach a land block, I'm breaking over that. Okay, so I'm reaching the first possible land. If current is greater than or equal to N plus 1, that means we have reached the end. So we can stop. If current is greater than or equal to N plus 1, we can just stop at that point. Because like we have reached the other bank. Otherwise, if current minus 1, like string current minus 1, like why I'm doing minus 1 is you need like current is 1 index right now and I'm converting it into 0 indexed. So yeah. So if that position of the string is a land, I'm continuing because we have already reached a land. And the only assumption that I want to move to the next iteration of the loop is going to be that that position is a land block, not a water block or a crocodile block. If the position that I reach is a crocodile, I break over there because if you reach a crocodile, that's it. You can't move any further and I break at that point. Otherwise, I try to swim. I try to swim as much as possible such that I reach a land block. If I reach a land block, I break over there. If I reach a crocodile block in the middle, I break over that. But I said done is equal to false. Done is basically just a parameter, the variable that I'm setting to true at the beginning. And if it is proven in the middle that it's not going to be possible to reach the end, I'm setting done is equal to false. That's basically what I'm doing with done. So yeah. Then I'm trying to swim as much as possible, and if I reach a land, I break over there. But even if after I swim as much as possible, I don't reach a land, but rather just reach a water block. What I do is I'll just break at that point, because you have swam all my like you have swam the maximum limit you can swim, but still you haven't reached a land block. So this implies that it is never going to be possible to reach a land block. Therefore, it is not going to be possible to reach the other end of the river. So in this case, the output would be false. So yeah, if done is true, I output yes. Otherwise, I would output no. That's basically the way to solve this problem. Okay. Yeah. Okay. What if it's a C? Okay. So while jumping, you will just jump over the sea. Okay. So that doesn't matter. Over here, it doesn't matter. I hope that made sense. In the other so even if you after you jump the maximum length, say that position is a crocodile. So if that position is a crocodile, you break at that point, because even after you jump that much, you would be reaching a point which is a crocodile eventually. So you wouldn't be able to cross that in any way. So that done is going to be set to false. Otherwise, while swimming, if you reach a crocodile in the middle, then you would be breaking. You can't cross that point. So even in that case, done is going to be set to false. I suppose we have only question was with this for block why the crocodile case isn't dealt with. The reason why we are in dealing with the crocodile case is because we are jumping over here. Even if there is a crocodile, we can just jump over it directly. We wouldn't have to cross that. Okay. I hope that made sense. Is your doubt clear?
Yeah, actually, my doubt was so what if we jump over the crocodile? Like, the maximum M is the crocodile. Then...
You mean what if like the maximum jump you do is a crocodile? Okay,
Yeah,
so okay, so what if the what if the maximum jump you do is a crocodile? That assumes that there is no land block in the middle. If there is a land block in the middle, you'll obviously stand at that land block. Okay, but otherwise, you try to jump the maximum distance. If say maximum -1 is a water block, I suppose what you're asking is instead of jumping on the crocodile, what if you just jump before that if it's like a water block? Is that your question?
yeah,
Okay, even if the previous thing is a water block, eventually when you swim, you would have to swim through the crocodile, right? So if you swim through the crocodile, you wouldn't be able to swim through the crocodile. That's why it's like it's essentially the same thing to jump on the water block, then swim to the crocodile, or directly jump on the crocodile. That's really. Does that make sense? Oh,
yeah.
okay, cool. Yeah. Okay, that was basically it for the problem D. That was basically just like an simple simulation and implementation problem. Okay, maybe a little annoying, but yeah, that's so. Okay, this was an interesting problem. It is kind of like okay, kind of tricky to implement, but yeah, it was quite an interesting problem. In this problem, one second, in this problem, this person Noobish Monk has n friends. Each of his n friends give him a apples. Okay, so he would have a into n apples after that, and from those a into n apples, he's returning b apples back to his friends. So after that, he would have n into a minus b apples. So this person over here, Kuhn is writing a program to calculate the number of apples that this person would be getting. Okay. He wrote this program, but one mistake that he did was instead of inputting n as an integer, he inputted it as a string. So yeah, so I suppose he's coding in Python. That's why this problem is happening. And so he's concatenating. So in this case, what happens is n into a is being represented as, since it's n is a string, it's being represented as replication of n. That is n plus n a times. That's what n into a is becoming, since n is a string. And when you subtract b from n into a, the last b characters of n is of that string is removed. So what is it like? I'll just showcase an example. Say the number you have is say n is equal to 25 and a is equal to 3 and b is equal to 3. What would happen is n into a would give us 25, 25, 25. That's what will happen, n into a. And n into a minus b, subtracting b from this will give us, remove these three values and would give us 2, 5, 2 as the output. So what we need to calculate is, for a given n, the number of a comma b such that the value of n into a minus b string, okay, when n is a string, is equal to n into a minus b when n is an integer. So the number of pairs a comma b is what you need to calculate. Okay, so I hope the problem statement made sense. Are there any doubts in the problem statement so far? Okay, I don't think there are any doubts now. So, okay, cool. So I move on to the solution of this problem. How you'll be solving this problem is, the most important thing with this problem is noting the constraints of A and B. It's quite weird that A and B have like constraints of 10,000 and 10,000. In normal cases, if the values are not going to matter for the complexity, a bigger value might be given. Like A might be like, say, 10 to the power 9 and B might be 10 to the power 9. So immediately after looking at the problem, it seemed quite difficult. So what I did was, is there a way to like use these constraints to solve it? So what I tried to do was, I loop for all possible values of A. Okay, all possible values of A from 1 to 10,000. So for all possible values of A, and n is from 1 to 100. Okay, n is from 1 to 100. That's the constraint for n that's given in the problem statement. So n can be any value between 1 to 100. You loop A from 1 to 10,000, and I just calculated the value V is equal to n into A. N into A, this is not like string multiplication, but rather just normal multiplication. V is the product of n into A. So say the length of V is some length L. Length of V, L is equal to the length of V. V is an integer, but by the length of V, what I mean is, say the V is 153, length of V would be 3. That's basically what I mean by length of V. Okay. So let's say L is the length of V. The concatenation of n into A would give us some value. It will give us some long string. Okay. If n is a string, and n into A will give us some very long string. But one thing to notice is the length of V can be at most L. So the value B should be such that the concatenation of n into A, whatever the length of n into A is, that minus b should be equal to this length, or less than or equal to this length. Okay. So b can be only some particular sets of values. So does this point make sense? Like the b can only be particular sets of values because b is so chosen such that n the string n into a minus b gives us values of this particular length. So did this point make sense? I hope it made sense. If there are any doubts, feel free to ask. So yeah. Yeah. So we calculate the layer. Yeah. Okay, not understood. Okay. Yeah. Okay. I'll try to explain this again. I'll try to explain this part again. So let's say V is equal to Vs. Okay. Vs is equal to n into a when n is a string. So the definition of n into a when n is a string was discussed earlier. So that's basically just a concatenation of repetition of n multiple times, repetition of n a times. Let's say ls is the length of vs. Length of vs. Okay, let's say that that's what ls is. Something that we need to ensure is that after subtracting b from ls and b from after subtracting b from vs and b from v, the length of both those things should be same, because we need v and vs to be same after subtracting b from both. So for that, the length of the vs and v needs to be same, obviously, for the numbers to be equal. Did this point make sense? What I mean over here is, what we need is n into a. Yeah, okay, that made sense. So n into a minus b when n is a string, and n into a minus b when n is an integer. Both of these need to be equal. So obviously the length should also be equal. The length of the integers need to be equal. So what we need to make sure is that n into a minus b would give us some integer. The length of this integer is going to be length of this integer. Okay, length of this thing is going to be less than or equal to this thing is going to be less than or equal to L. Okay, so n into a minus b is going to be less than or equal to the length of n into a. This is obvious because when you subtract something from an integer, it's subtract a positive number from another integer, it's going to decrease. And when the integer is smaller, the length of that is going to be smaller than or equal to that original length. Okay, so you only need to check for integer, check for cases where, check for all the b's where len of vs minus that b gives us something which is less than or equal to L. Does this point make sense? What I mean over here? Because since n into a minus b, okay, since n into a minus b is going to give something with length less than or equal to L, even after subtracting the b from the string, we would want things which have length less than or equal to L. So, okay, so there would only be some cases of b's, okay, there can only be some possible b's which can be considered. Does this point make sense? I hope that made sense. If there are any questions, okay, cool. If there are any questions, feel free to ask now. I'll just explain it if you want. Okay. So yeah, I'm assuming it made sense for everyone. So we can move on to the next point. So we'll just consider the case where we'll now look at the case where n into a is that integer. When n is that integer, n into a is going to be some value. We'll just consider the most extreme case. In the most extreme case, in the sense the largest case, n is as big as possible and a is as big as possible. When n is as big as possible, the maximum value of n is 100. The maximum value of a is 10,000. So the maximum value of n into a is going to be 10 to the power 6, which is 1 followed by 6 zeros. 6 zeros. This is going to be the maximum possible value of n into a. The length of this is going to be 7. Okay. Length of this is going to be 7. So in the string case, n into a can be something very big. N into a can be anything very large. Okay. Yeah. N into a can be something very large and the length can be very big. We can't afford to compute this because that will be taking a long time. But on the other hand, what you can notice is, irrespective of all what length n into a is, the length of n into a would be calculated by us. Length of n into a would be length of the string n into a. Okay, so the length of n into a would be calculated. Let's say this length is ls. We want to find a b such that ls minus b is less than or equal to l. Okay, so there are only going to be like 7 such possible values of b, because l is at most 7. So we'd only need to check for 7 possible values of b. ls is going to be a constant for a fixed n and a, because that ls is going to be a fixed value for that. And for that particular ls, there are only going to be some particular values of b's. Okay. So did this point make sense? There are only going to be some limited number of b's. If this didn't make sense, feel free to ask in the chat. Otherwise, we'd move on. Okay, cool. Okay, so you only select those particular b values. There are 7 such b values. Those can easily be computed. What are those 7 such b values? We'll just move b to one side and all the other constants to the other side. So b is going to be ls minus l. So yeah, we'd have those 7 such b values, and yeah, b needs to be greater than or equal to ls minus l. So yeah, any value which satisfies this equation, but also yeah, obviously b needs to be less than or equal to ls in length. Okay. The reason is you can't like just remove all of the b's. Actually, it should be less than ls. Since in the problem statement, it was said that you cannot have an empty string. An empty string is not a valid integer. Okay. So this is the basically the inequality. And you'd loop for b, you'd check from all values from ls minus l till ls minus 1. Those are all the possible values of b. Okay, you loop through all these possible values and compute both of these. That is n into a minus b for strings and n into a minus b for integers. Computing this is trivial. It's going to be very straightforward, and it's not going to be something that's just going to be a mathematical expression that's easy to code up. But for a string, the string case, it is slightly trickier to code up. I will showcase how I coded that up when I explain the code. Okay, so the coding of this part is slightly trickier because you generally you can't afford to just multiply this that many times. Can you actually do that? I suppose it is. It might be fine to do that too, I guess, because Okay, yeah. I suppose you could also do it naively. So what would be the complexity of that? Okay, no, I don't think that would be allowed because if you do this naively. Okay, no, I don't think that's going to be viable. No, yeah. Okay. Computing this part fast enough might be tricky, but I suppose a naive way would also work. For each I from 1 to A, you could basically just simulate the process of creating that string and remove the last parts. That should also work, I guess. But I tried to do this faster in my code, and it was a bit tricky to do this fast enough. But did up to this, did this pattern make sense? Except the implementing this part, did everything make sense so far? If there are any doubts so far, just say in the chat. Otherwise, just say. Okay, cool. So no doubts so far. Okay, cool. So I'll just showcase how I implemented this part. So yeah, okay. You have one integer, which is v is equal to n into a minus b that I'm computing over here. This is the integer value that I have computed. For the string thing, what I'm doing is I'm setting v2 is equal to 0. Okay, v2 is the I'm just setting it. I'll compute it as an integer. Okay, the computation I'm doing it as an integer, but this is representing that string part of the problem. Okay, so that's what I'm computing with v2. So how I'm doing it is I'm initially computing this vector vi. What I'm doing in this vector vi is I'm splitting each digit of the number n. Okay, I'm splitting each digit of the number n. So suppose it is 123. Suppose the number is okay. Let's say the number is 157. Let's say n is equal to 157. Vec is equal to 1 comma 5 comma 7. That's what I'm storing in vector. And after that, yeah, I'm storing that in the vector. That's what I'm doing in this part of the code. Basically this. And I'm also computing the length of n again because that's useful in the forward steps. And yeah, after computing the length of the vector, length of the vector, and this particular vector is computed. Okay, I'm storing that vector, and after that, what I'm doing is v2 is representing the string, and I'm looping from C minus B. C minus B is the length that we need. What is C? C is equal to L into A. The C is the length of the string before removing B characters. Okay, so L is the length of N and A is the number of times you're repeating N. So C is the length of the entire string before removing B characters. That is what C is. Okay. So yeah, and C minus B is the final length of the string. So I'm looping from looping C minus B times. Okay, I'm looping C minus B times and adding the last character, like adding the characters one by one. I'm adding the first character in the first iteration, second in the second iteration, and so on. The first character is going to be the first character of n. Okay, first character of v2 is going to be the first character of n. I'm adding that. and in the next iteration that is going to be pushed to one step forward. So in the first step it will be in the ones place, and I'm multiplying it by 10 to move it to the hundredth place, and I'm adding the next character and so on, and I'm repeating this c minus b times. So J model would indicate the current character that needs to be stored. So if the index is 0, then it will give the 0th character. If the index and if the length is 3 and the index is 3, it will again give the, say the 0th character needs to be added right now, and so on. That's basically what is happening over here. I hope that made sense up to that, up to this point. If V2 and V are equal, I'm appending A comma B to the output vector. Okay, if V2 and V are equal, I'm so V2 is the string thing and V is the integer thing. If both are equal, I'm appending A comma B to the output. And finally, I'm outputting like it was mentioned in the problem statement. Did the explanation to this problem make sense? Did like the way I coded, especially the string part, how I computed for the string, did that make sense? Oh, okay, sorry. So yeah, that was PB is basically just pushback. I'm sorry, I forgot to mention what the template was. PB is basically pushback in my code. Okay. So yeah, and MP is make pair. Okay, MP is make underscore pair. That's basically just STL functions. Out is a vector. Out is a pair vector containing pairs. I is a vector of pairs. That's what I have over here. Okay, cool. So yeah, I suppose we can move on to the next problem now. Valuable cards. Okay. Did you guys get time to read this problem statement during the contest? I'll explain it now, anyways. So in this problem statement, okay, cool. We are given n cards. In each of these cards, there is an integer AI written on it. Okay. And none of these integers contains the value x. None of these integers contains the value x. So we are trying to divide these cards into a many number of segments such that there are two conditions that need to be satisfied. Okay. The condition that needs to be satisfied is in all of these segments that we divide these cards into, there are no set of elements such that the product of all these elements equal to x. Okay. Sorry, Aditya, I need to explain the question, I guess, because I'll just explain it quickly. I'll explain it in a minute. Okay. So I'll explain it quickly. So basically in this problem, you're trying to split this array into many segments such that in all of these segments, there are no subset of elements such that the product of those elements is equal to x. There should be no subset such that the product of all those elements in the subset is equal to x. That needs to be ensured. And yeah, that's basically it. And you need to find a way such that you can split it into minimum number of such subsegments. Okay, so a minimum number of subsegments such that there is no subset in each of these subsegments which product equal to x. That is basically what you need to solve for in this problem. So one fact or something that is easy to derive is that given an integer x, the number of numbers which are divisible by this integer is O of root of x. Okay, O of root x. Okay, do you know this? Is this something that you know? Proving this is quite simple. The reason why it's O of root x is for an integer, it's going to have it can be split into two divisors. So let's say you have x and it's divisible by 2, you can make it 2 and x. Then yeah, that's going to be one pair of divisors. Up to only up to root x, you can have like a unique pair. Beyond root x, if you have another number, say root x plus 10, that would have already been counted in a previous pair. Root x plus 10 would have been counted along with the previous thing. So this can be proven. I'm not proving this right now. So I hope you knew this. Did you know this fact already, Aditya? For a particular number, the number of divisors of that number is O of root x. Okay. So that's an important fact to solve this problem. So that's something that we'd be starting with as our base. Yeah. Another thing that you need to notice is that you have an array of n elements. Okay, once again, I'll just take a sample test case. I'll just take one of the sample test case. This is the first sample test case. I'll try to explain with this. So at the beginning, you'll try to pick all the elements such that, okay, you start at the first position and you keep picking elements up to the point where the condition is not satisfied anymore. The condition that the subset product of a particular subset is equal to x. If that becomes true, you cannot include that element in that current subsegment. So you can pick the first element because in the first test case, x was equal to 4. You can pick the first element, then you can again pick the second element. Okay. Still this condition is not violated. You can pick the third element, condition is not violated so far. You cannot pick the fourth element. The reason is if you pick the fourth element, the product of the first and the fourth element is equal to 4. And the condition is violated. So that is not going to be allowed. So 2, 3, 4 are the elements that you can pick. Sorry, 2, 3, 6 are the elements that you can pick, and you stop at this point. This is going to be one segment. Then next, you start at the second segment, move to the next element. You can pick 1. Okay, so far it is not violated, but you can't pick 2. So you have to stop at this point. So another segment is done, and 2 is going to be one separate segment. So the answer for this test case would be 3. Okay, so yeah, you can greedily keep picking elements till the condition is violated. That's what I'm showing over here. Okay, so you're allowed to do it greedily. The reason is even if you stop over here and start from x, it's not start from 6. It's not going to improve the case for the next array. It's better to keep 6 over here and then move on to the next array. It's not going to be similar to have 6 over here or here. In some cases, it might be worse having 6 in the next set. So it's ideal to keep greedily picking till the point where it's no longer possible to pick. Okay, so that is something that that we are doing over here. So such a greedy strategy will work. That's what I'm showing over here. So after this, the only step that is left is see how to find that condition mentioned over there is violated. How to find a point where the subset is equal to this product. Okay, subset is equal to this product. That is something that you would need to see. Okay, that is basically what is left of this problem. So how do you do that? So to do this, what you try to do is maintain a set. Okay, maintain a set. What the set would contain is the set would contain all the elements such that if this element or a set of elements such that the product to this particular element is found in the future, then it is going to be possible to form X. Okay, I suppose the definition of the set is going to be complicated. Okay? Okay, so basically this set will contain elements such that if you find elements in the future with which product to X, okay, if you find elements in the future such that those product to X, then it is not going to be possible to, then it is going to be possible to form X. That's basically what it will contain. So initially the set will only contain X. Then in the next step, what will happen is this set for this array, okay, initially the set is going to contain only X, which is 4. Then in the next step, you see that the first element that you encounter is 2. You first check whether 2 is present in the set. If 2 is present in the set, that means that if you have another additional 2, then it is going to be possible to attain X. So if 2 is not present in the set, what you do is you loop through all the elements in the set and add that element divided by 2 to the set again. So yeah, that's basically what you'll be doing. So yeah, after adding 2, you'd have 4, 2 to the in the set. Then after that, you'd see 3. 3 is not present in the set. And you try to add 4 divided by 3 into the set, but 3 is not divided by 4, divisible by 4. So you don't need to check, try to add 3 in this case. And similarly, 3 is not divisible by 2, and you don't need to add 3. Similarly, even with 6, the same thing. 6 is not divisible by 4 is not divisible by 6, or 2 is not divisible by 6. So you don't need to worry about 6. Then you come to 2. 2 is present in the set. So that implies that since you found a 2 now, it should be possible to form a 4. Okay, it is going to be possible to form a 4. So that means that it's going to be ideal to empty the set right now. It is going to be ideal to empty the set at this point. Okay. Did that part make sense, or should I try to explain it in a different way? If it did not make sense, feel free to say in the chat. I'll try to explain it. Okay, I suppose it did not make sense entirely. Okay, I'll try to explain it in a simpler way. Another way that you could possibly look at it is, instead of storing all these elements, which are like, we'll define the set differently. What we do is the set will contain all the values that are possible to be formed so far, which are divisible by X. So the elements in the set X will only contain values which are divisible by X. Okay, so those are the elements that would be contained in set X. Okay, set, and those would be possible to be formed with the segment which is which we have so far. So for the sample test case we had earlier, what is the sample test case again? 236212. 236212 and X is equal to 4. Okay. So yeah. We would and the first segment initially set is going to be empty. Okay, so far the segment is empty, so the set is empty. Then we start off with 2. Okay, we start off with 2, and 2 is divisible by 4. Okay, so we insert 2 to the set. Then the set will become 2. Okay, so 2 is the one day element in the set. This is going to be the set. Then the next element we have is 3. What we do is we loop through each of the elements of this set and see whether 3 into 2 is equal to 4. If 3 into 2 is equal to 4, we need to break the segment so far and stop at this point. This question rating would be like, I suppose, what is this? I suppose it's going to be like 1800-ish. 1800 should be a valid rating for this problem. Yeah, I suppose it would be 1800. So yeah. So yeah, 2 is going to be the initial subsegment and 2 would be inserted into the set. Okay. After 2 is inserted, you have the next element 3. Okay. You loop through each element of the set and see whether 3 into 2, 3 into that element is equal to 4. If it is equal to that, if it is equal to 4, then you have to break at the previous point and 3 would start like a new segment. But that's not true. 3 into 2 is not equal to 4. And so what you try to do is you'll check whether 3 is divisible by 4. But 3 is not divisible by, 4 is divisible by 3, but 4 is not divisible by 3. So you don't need to insert 3 into the set. And another thing you'd be checking is whether 3 into 2 is also divisible by, 4 is divisible by 3 into 2, which is again not true. So you don't need to insert 3 into the set. So the set so far only contains 2. Then with 6, the same logic can be applied, and you'd see after considering up to this point, only 2 would be the element in the set. Then when you move on to this 2, you'd see whether 2 into 2 is equal to x. Okay. If 2 into 2 is equal to x, then you can stop at that point. If 2 into 2 is equal to x, then you can see that if 2 is added to the set, if 2 is added to the current segment, then the condition where some set of product of some set of values is equal to 4 is satisfied. So 2 cannot be added. So you stop the segment over here, and now you can just clear the set again and start from the beginning again. You have an empty set, then you move to this 2, insert this 2 into the set. Then you again check the same thing with 1. If you check with 1, you cannot get 4 with just this 1. So you can continue, but with the 2 again, by the similar logic, you'd get 4 at that point. So you'd have to break the segment over here. Okay. So the segments that you'd have is, this would be one segment. This would be one segment, and that would be one segment. The reason why this would not exceed time limit is the length of the set is not going to exceed root of x. Okay. The reason why it will not exceed root of x is obvious. It's same as the logic that I told earlier. The number of divisors for x is going to be O of root x, and the length of x is bounded by the number of divisors. Okay. So yeah, the length of set is not going to exceed O of root x. So the total time complexity would be n root x log x. Log x because we are using a set over here. Okay. I suppose it's going to be possible to do it without the log x, maybe a knotted set or something else, but not necessary right now. You can just do it right this way. So yeah, O of n root x log x would be the time complexity to solve this. So I'll try to explain the same thing with a different test case, okay, which would make things a bit more clearer. But did parts of this make sense so far? Like, if there are particular things that you did not understand so far, just feel free to unmute and ask. Okay, cool. Nice. Okay, I'll just take one more test case and try to explain it just explain one part of it. Okay, let's just take this test case. 5, 2, 2, 3 and x is equal to 1. This is just to explain one particular part of it which wasn't covered with the previous test case. So initially set is going to be empty. Okay, set is going to be empty. And you start with this 5, sorry, x is equal to 20. Okay, so x is going to be 20 in this case. X is 20 and you start at 5. 20 is divisible by 5. So you insert 5 into the set. Then you move on to 2. 2 into 5 is not equal to 20. So you can continue. You can add 20 into, you can add 2 into the current segment. Then you'd see whether 2 is divisible by 20. Since 2 is divisible by 20, you add 2 to the set. Okay, so 2 is the divisor. So say this set will contain all possible divisors which can be formed so far. Since 2 is a divisor, you add that to the set. And 5 into 2 is also divisible by 20. When you have 2, you loop through all the elements of the set so far, and 5 into 2 is also divisible by 20. So you add 5 into 2, 10 into the set. Okay, so the set after up till this point will contain 5, 2, and 10. These are the 3 divisors which can be formed. Okay, after this, when you consider this 2, okay, when you consider this 2 into 5 is not equal to 20, 2 into 2 is not equal to 20, but 2 into 10 is equal to 20. So if you consider this 2, there is a subset such that all the product of all those elements is equal to 20. So this 2, if you include this in the segment, the condition is violated. So you cannot have this in the segment. So up to this point needs to be one entire segment, and you need to create a new segment after this. So the set is going to be emptied now. After emptying the set now, you would have 2 as our next element. Okay. 2 is the next element of the array. Then with 3, you'd see whether 3 into 2 is 20, which is not true, and 3 is not divisible by 20, so you can ignore. And the output for this case would be 2. Okay, I hope it made sense what I'm doing over here. Like what I'm representing the set. The set basically represent all the possible devices that can be formed so far, and the sides of the set is going to be bounded by O of root n. For each value, O of root x. That's O of root x. So for each element, you would be looping through all of these O of root x values. And since there would be n elements and looping to root x values, and the set inserting into the set would be a log of root x complexity. In total, this is going to be like n root x into log of root x. That is going to be the time complexity. So yeah, O of n root x into log of root x would be the final time complexity. So I hope it made sense. Are there any doubts so far? I'll just move on to the code otherwise. I personally found this problem to be harder than problem G. I found solved problem G quicker than this one, but okay. So I hope there are no doubts so far. If there are no doubts, I'll just move on to the code. The thing is, the code that I wrote was different from what I explained. Okay, this is slightly different. The code that I wrote is the first explanation. Okay, so in this thing, the set represents all the values that are required to get to x instead of all the divisors of x so far. That is the difference in my code. But other than that, it is basically the same code. Okay. So yeah, I suppose we can move on to problem G then. If there are any doubts, feel free to ask now. Okay, cool. Yeah, then we can move on. After implementation is easy. Okay. So yeah. Okay. Do you know what the MEX operator is? Maximum excluded integer. I suppose you know that. Otherwise, I'll just quickly explain it. Here, the MEX operator is defined slightly differently. In this problem, for us, okay, cool. In this problem, on the other hand, it is like defined in a slightly different way. Okay. For a particular set of elements, the MEX of that set MEX over here, this S is a set, okay? S is a set of elements, and another parameter K is given. Yes, smallest positive integer not present, but here it is slightly different, okay? Here, what they're doing is they're finding the K smallest positive integers that are not present. So say you have 2, 3, 5, and 7 as our set, and K is equal to 3. K is equal to 3, then MEX S comma K would be the third smallest positive integer not present. So the positive integers not present are 1, 4, and 6. And 8, 9, and so on. There are many such so on. But the third smallest positive integer not present is 6. So for this particular case, the output would be 6 for this operator. Okay. That is how the operator is defined for this problem. Another operator that is given is me of an array A. Meow of an array A is the M is defined as the sum of MEX B comma len of B plus 1 for all B is all the B is all the possible subsets of A. Okay, so all the possible subsets of B is the is B. So MEX of all possible subsets is what is calculated, and the sum of this value is what we need to find out. That is basically the problem. And A is a permutation of all integers from 1 to n. So A is basically 1 to n. Okay, so that's what A is. So did the problem make sense? Did the problem statement make sense? If it did, we can move on to the solution. And yeah, n is up to 5,000. So since n is up to 5,000, we can since n is up to 5,000, we can have an O of n square solution. That's basically what it indicates quickly. So yeah, this is basically a combinatorics problem. What we need to notice is that we'll have this variable total, which contains the output. Okay, this contains the entire total that we need to output. Initially, we'll just set it to 0. That is a particular case which we'll just handle quickly at the beginning, which is the empty subset. Okay, so MEX of the empty set, comma 1. The size of empty set is 0. So 0 plus 1 is 1. So MEX of the empty subset, comma 1. So the output for this would be equal to 1. So we just increment total by 1 at the beginning. Total plus equal to 1. So yeah. After doing that, next what we do is we loop through all of for I from 1 to n. So what we are looping through is all the lengths of the array from 1 to n. So length of the subset is 1, length of the subset is 2, and so on. So for all possible subset lengths, we are trying to calculate the contribution, okay, contribution to the sum. So when the subset length is 1, the value that we'll be calculating it is MEX. When the subset length is I, the value we'll be calculating is MEX of that subset, comma, I plus 1. The length is I, so the thing we'll be calculating is MEX x, comma, I plus 1, okay? So maximum excluded integer of S, I plus 1th maximum excluded integer of S is what we'll be finding out and adding to our contribution. We can obviously not iterate through all the subsets because that's going to be like 2 to the power n complexity, and that's not going to be ideal. So what we try to do is, how do we calculate this quickly? For all possible cases, how do we calculate this quickly? What we can see is that there are only going to be some set of possible MEX values that would be outputted, okay? There are only going to be some possible sets of MEX values that are outputted, and these values are going to be, let's represent this value to be J, okay? The possible MEX values. So the possible MEX values would be I plus 1, 2, 2 into I plus 1. Why is this? I'll explain why is this now, okay? So S, the length of S is I, okay? So one possible case is that S does not contain any element up till I, okay? If it does not contain any element up till I, then the I plus 1 smallest excluded element is going to be I plus 1, okay? So that's going to be the smallest possible case. And the other possibility is that S contains all the elements up to I. If it contains all the elements up to I, the smallest I plus 1 element not included is going to be 2 into I plus 1. So I hope both of these made sense. Wow, why this range exists. Did this make sense? Okay, cool. So I'll explain again. So S is a set with elements containing I elements. Okay, so S is a set containing I elements, and when S contains I elements, we will be computing MEX of S comma I plus 1. So length of S plus 1. That's what we'll be computing. So J is each of the possible MEX values. Okay, so each of the possible MEX values is what is stored in J. So we'll be looping from I plus 1 into 2 into I plus 1. And that is what we'll be looping with J. Okay, I plus 1 into 2 into I plus 1 is what we'll be looping for J. But why is this range formed? Why are these the possible set of values? That is because S can, for I plus 1 to be the output of this, or for I plus 1 to be the output, what we'd want is none of the first I elements are present. If none of the first I elements are present, the I plus 1 smallest possible integer not included in the set is going to be I plus 1. So that is why this is the lower limit. The reason why this is the upper limit, that is 2 into I plus 1 is the upper limit, is because the possible case for this happen is now all the I elements up to I are present. Okay, if all the I elements up to I are present, then the I plus 1 smallest element is going to be 2 into I plus 1. Because say we have I is equal to 2. Then both 1 comma 2 are present in the set, then the MEX of that set would be 5. Because MEX because I plus 1 smallest element not included would be 5. 3 comma 4 comma 5 won't be included, and 5 would be the third smallest element. So did that make sense now, or is it still unclear? Did this range make sense now? If it's unclear, I'll explain it again. Okay, cool. Good. So yeah, that's basically the range. Okay. So you loop j from I plus 1 to 2 into I plus 1. Okay. Then so in how many subsets do you get each of these possible j's? Okay, so that's what you need to add to total. Total is the variable that you're keeping track of. So to total, you need to add j into number of subsets with mex equal to j. So this is the only part that is left to be calculated. Once we calculate this, this problem can be solved. That's the last step. Okay. So how do we calculate this? So for the total to be equal to j, one thing that we need to ensure is that up to I, okay, up to I, that is sorry, up to j minus, yeah, up to j minus 1, yeah, up to j minus 1, j minus I plus 1 elements are chosen. Why is this so? This is because after we choose j minus I plus 1 elements, then from the remaining elements, the I plus 1 element would be the one we need. I'll just try to explain this with an example that will make this very clear. So so I is equal to 2 and I plus 1 is equal to 3. Okay. So up to j minus 1, j minus I plus 1 elements need to be chosen. That is up from 1, comma 2, comma 3, j minus I plus 1. That is one element needs to be chosen. Say you choose 2. Okay, say you choose 2. Then the excluded elements would be 1, comma 3, comma 4, comma 5, and so on. Okay, it's going to be so on. And the MEX value in this case would be 4, which is the value we need, which is j that we need. Okay, that's the reason why up to j minus 1, we need j minus I plus 1 elements to be chosen. Okay, to be chosen in our subset. So did this part make sense? That we need to, up to j minus 1, we need to choose j minus I plus 1 elements. Did it make sense? Okay, cool. So yeah, what is this? Choosing j minus I plus 1 elements from j minus 1 elements. That is just like the basic combinatorics expression. That is j minus 1 c j minus I plus 1. This can be computed in O of 1 using some pre-computation. Yeah, okay. So this part would be computed. This is one requirement, okay? So that is one thing. So the other thing is that other than this, there needs to be some other elements that needs to be picked. So j minus I plus 1 elements would already be picked. Other than this, there are going to be, in total, we need I elements. J minus I plus 1 elements are picked from here, okay? So other than this, we need another I minus j minus I plus 1 elements are left to be picked. These many elements are not picked from so far. So these needs to be picked. And from where can these elements be picked? These elements can be picked from the range j plus 1 till n. In this range, these elements are going to be picked, okay? Since n is the maximum possible element and j cannot be picked because j is the thing that needs to be excluded for this set. So from j plus 1 to n, these elements can be picked, okay? So that's basically what it is. So from j plus 1 to n, there are n minus j elements. Okay, so from j plus 1 to n, there are n minus j elements. And from that, from n minus j, we need to choose I minus j minus I plus 1. Okay, this is what needs to be chosen from n minus j. Okay. So these are the two paths that needs to be chosen. J minus 1, choose j minus I plus 1, and this expression. These are the two things that needs to be chosen. And the contribution of this part to the total, therefore, would be both of these can be multiplicated. So that would be the number of possible ways those subsets can be formed. This expression into this expression would give, so this expression into this expression would give us a required output, which is the number of subsets with MEX equal to J. Okay. I hope it made sense so far. Did any of these parts not make sense? If it did, please tell in chat. It made sense, right? So, or did it not make sense? I don't understand. Did you not understand? Did you not understand any part? Any part? Okay, cool. Okay, cool. So to the total value, you'd be adding this thing, j minus this is what you'll be adding to the total value. Okay. So yeah, the combinatorics expression would be calculated in O of 1, and you'll be looping from I from 1 to n and j from I plus 1 into 2 into I plus 1. So the overall complexity is going to be O of n square. Okay, O of n square is going to be the complexity of the solution. I hope the solution made sense. So now I'll just explain my code quickly. Okay, so it's pretty much the direct implementation of that. So the combinatorics thing is over here. I'm just computing that, and this is to compute the inverse. And one thing you need to make sure is the inverse is pre-computed. Otherwise, the computation of the inverse will take some time, and that will increase the overall complexity of the code, overall time complexity of the code. So to speed that up, you'd also compute the inverse initially and use that in the combinatorics function. Okay. And yeah, this is just the pre-computation part. And after that, I'm just doing whatever I had mentioned over that, looping from 1 to n and from I plus 1 to 2 into I plus 1. This is the loop for FORR loops from I plus 1 till 2 into I plus 2 minus 1. It stops at the previous thing. So it goes up to 2 into I plus 1, and it basically computes whatever I had told earlier. This is what it computes. Okay, that's basically just the same thing as what I told earlier. And yeah, that's basically it. If there are any doubts in any of the problems so far, feel free to ask. Otherwise, I'll end the PCD now. I hope there are no doubts. I'll just wait for like a minute, maybe, and otherwise. Yeah, you can search for the solution by searching my name. Otherwise, like after some time, while uploading my username is Aakash646. You can just search for my solutions if you do that. Otherwise, the solutions will anyways get posted in the YouTube video. The links would be posted in the YouTube video. Okay. So yeah, I'm ending the PCD now. So thank you guys.